Organopalladium chemistry is a branch of organometallic chemistry that deals with organic palladium compounds and the reactions. Palladium is often used as a catalyst in the reduction of alkenes and alkynes with hydrogen. This process involves the formation of a palladium-carbon covalent bond. Palladium is also prominent in carbon-carbon coupling reactions, as demonstrated in tandem reactions. Organopalladium chemistry timeline. 1873 A.N. Zayzyev reports reduction of benzophenone over palladium with hydrogen. 1894 Phillips reports that palladium 2 chloride reduces to palladium metal by contact with ethylene. 1907 Autoclave technology introduced by W. Ignatieff makes it possible to carry out high-pressure hydrogenation. 1956 In the Wacker process, ethylene and oxygen react to acetaldehyde with catalyst PdCl2, copper 2 chloride. 1972 The Heck reaction is a coupling reaction of a halogenide with an olefine. The catalyst is Pd. 0. 1973 The Trost asymmetric allylic alkylation is a nucleophilic substitution. 1975 The Sonogashira coupling is a coupling reaction of terminal alkenes with aryl vinyl halides. Overview. In contrast to its next-door neighbors the group 11 elements, the element palladium in organic chemistry does not involve preparation of organopalladium compounds itself, but rather organopalladium reactive intermediates. On top of that, in many reactions only catalytical amounts of the metal are used. Palladium-alkene complexes. Palladium reacts with alkenes to form a pi complex which can react with a multitude of nucleophiles. Akin deoxymercuration reaction. The CPD bond is then removed by a reduction or an elimination. In the industrially important Wacker process, ethylene is converted to acetaldehyde with palladium chloride. Fullerene ligands also bind with palladium in similar ways as ethylene. Palladium-allyl complexes. Allyl compounds with suitable leaving groups react with palladium 2 salts to pi-allyl complexes having hapticity 3 such as the allyl palladium chloride dimer. These intermediates too react with nucleophiles, for example carbanions derived from malonates or with amines in allylic amination as depicted below. Allyl palladium intermediates also feature in the Trost asymmetric allylic alkylation and the Carroll rearrangement and an oxo variation in the Seguso oxidation. Palladium-carbon sigma-bonded complexes. Various organic groups can bound to palladium and form stable sigma-bonded complexes. Currently, the alkyl, vinyl, aryl, and alkynyl complexes with PDC, sp3, PDC, sp2, PDC, sp bonds are equally well known. The stability of the bonds in terms of bond dissociation energy follows the trend PD alkynyl greater than PD vinyl approximately equals PD aryl greater than PD alkyl, and the metal-carbon bond length changes in the opposite direction. PD alkynyl less than PD vinyl approximately equals PD aryl less than PD alkyl. Palladium insertion compounds. 0-valent PD. 0. Compounds such as tris, dibenzylide and acetone, dipalladium. 0. And tetrakis, triphenylphosphine, palladium. 0. React with halocarbon Rx in oxidative addition to RPDX intermediates with covalent PDC bonds. This chemistry forms the basis of a large class of organic reactions called coupling reactions. See palladium-catalyzed coupling reactions. An example is the Sonogashira reaction. Palladium 2 trifluoroacetate has been demonstrated to be effective in aromatic decarboxylation. In the proposed reaction mechanism, PD 2 replaces the carboxylic acid proton while losing a TFA group. Carbon dioxide is lost in a first-order reaction and TFA destroys the formed RPD-TFA complex, without PD changing its oxidation state. Organopalladium IV. The first organopalladium IV compound was described in 1986. This complex is Me3PD IV. IBPY with BPY as a bidentate 22 bipyridine ligand. It was synthesized by reaction of methyl iodide with Me2PD 2 BPY. Palladium compounds owe their reactivity to the ease of interconversion between PD 0 and palladium 2 intermediates. There is no conclusive evidence, however, for the involvement of PD 2 to PD IV conversions in palladium-mediated organometallic reactions. One reaction invoking such mechanism was described in 2000 and concerned a Heck reaction. This reaction was accompanied by a 15-hydrogen shift in the presence of amines. The hydride shift was envisaged as taking place through a PD IV metallocycle. In related work, the intermediate associated with a hydride shift remains PD 2, and in other work, a novel synthesis of indiols with 2 PD migrations. Equilibria are postulated between different palladicycles, and in certain intramolecular couplings synthetic value was demonstrated regardless of oxidation state. See also compounds of carbon with other elements in the periodic table.